Okay, hello, hello, hello. How are we doing? I think we're okay here. That was weird, man. I don't know what's going on there. Let me check the stream health. Everything's fine. I think we're okay here. Sorry about that. I don't know what happened. The stream just dropped. Okay, you know. All right, great. Yeah, that was really odd. So what I was doing was I was explaining 1605. I really, in my opinion, very clever approach. That was correct. Actually, I tried it and it was correct. So reading it again quickly, you get a row sum and a column sum of a 2D matrix, and you've got to create the matrix that has that row sum and column sum. So 3, 0 for the row gives you 3, 1, 7 gives you 8. That's the row sum, and then column sum, 3, 1 gives you 4, 0, 7 gives you 7. And you've got to recreate that 2D matrix and try to do it efficiently. And so the solution that I came up with, the idea after I thought about it for a while, I thought of it as, think of it as like a points. So the sum of the row sums and the sum of the column sums are both going to be the sum of all of the amounts in the matrix, which is sort of like all the points in the matrix. And in that sense, you could think of it as if you go row by row and you have like the numbers of the points for each row and the points for each column, you could distribute for each row all the points of that row across the columns. And then as long as you distribute, like since you're going to distribute all of the points, the number of points that need to be distributed from the rows into the columns, it's equal. So it's the same number of points in both the columns and the rows in total. So as long as you distribute all of the row points across the columns, you're in good shape. So the easiest way to do that is to just take the minimum of the row sum and the column sum at each iteration, decrement it from both sides, and basically distribute as much of the row as you can into each column, and do that from left to right for each row, and that'll give you a very concise solution that's linear in the number of elements of the result, or m by n in this case. So very straightforward, actually. And that's what I did. And ended up being very efficient. Yeah. So a pretty good solution. Let me see. Okay, so it is. So I am having some issues though with. That was. I am having some issues though with the. Okay, it looks like we're okay. Odd. Just give me 1 second. Yeah. Oh, wait. Hold on. Oh. Hold on a minute. Strange. I think we're okay. I'm gonna refresh this. It's actually not as efficient as I thought it would be. What am I missing here? Yeah, okay. Looks like we're what am I missing? Yeah, we're good. We're good. Okay. Yeah, okay. Sorry about that. Yeah, so it ended up being a very clean solution. Surprised though that I'm not getting the I'm not getting 0 milliseconds though. It's about as efficient as I can make it. Let me see if there's some. I'm gonna ask the chatbot, see if I can get anything. Can you help me optimize this? Curious to see if maybe the chatbot says it needs to see the code first. Give it a moment to finish. All right, it's fine. I don't know why I'm not getting the 0 milliseconds here though. There's something about this that's not as efficient as it could be. Yeah, I'm not sure why though. Let's greedy approach O of n times n times complexity, optimized version that reduces unnecessary iterations. Okay. Okay. Remove this condition. Naturally handles 0 values. The check is redundant. Huh. 2-pointer optimization. Sums are sparse. Interesting. Interesting. 2-pointer approach is m plus n time complexity in practice by limiting 0 sum row columns early. Oh, 2-pointer approach. Give that a shot. Let's do. As I said, just remove this. Okay. We'll try the 2-pointer approach. I mean, I would think the compiler would just kind of optimize this or something. Like, I don't think this actually is going to make it much faster. Find out in a minute. Let's check the stream health is okay. All right. Still correct. Let's see how fast it is. No. No, the other idea I had was faster. Didn't actually make things faster. What is this 2-pointer approach though? What is that? That might make things faster. Let's try one more time. So get this value, decrement, and then it suggests if the row sum is 0, then we increment the row. Column sum is 0, increment the column. That's interesting. That's a peculiar way of doing it. Let's take a look at that. Yeah, we shouldn't revisit columns. Okay. So I can just optimize this. So this will be a very similar thing. I just optimize it with C0. Start at start. Start equals 0. We'll just say here if sum of start 0. Basically, something like this. Kind of a slight optimization. I think this is still correct. We'll see. Yeah, there we go. That's a lot faster. There we go. This is effectively the 2-pointer solution, just written slightly differently. So it still does the same thing, except what it's going to do now is when the column is 0, it's going to skip those initial columns. Yeah, not distribute over multiple columns. Well, actually, yeah, because it might need to start. It might need to distribute over multiple columns. I wonder if it's the same as this other 2-pointer solution. It's very similar. It's effectively the same thing. So maybe it's not the same thing. Well, so this row, it's gonna distribute the entire row sum across anyway. So this is gonna be 0 after at every iteration anyway. The question is, how far does it need to go to distribute? And yeah. I also don't need an if statement here. Something tells me it's not quite the same. Maybe I'm wrong. So there are a few instances where this doesn't increment start, and that's when basically the row sum is smaller, in which case it would iterate R a few times. Yeah, I mean, this is very similar to the other two-pointer approach. That's with using a while loop. Interesting. I'm not sure which one's faster. I don't know. I could try the explicit two-pointer approach. We're not going to use. I'm not going to use the while statement. I don't dislike it. Yeah, well, I guess it is going to be effectively O of n plus n time, because one of these is going to be 0 at every step. This is cleaner, I think, than the other one. I do think this is a little bit better. It's an interesting question now. Let's see. This thing here. So we're getting a little bit of buffer, a little bit of buffering here. Let's see. About 13 minutes in, 14 minutes in. A little bit of buffering. There we go. Okay. Just give it a minute here. Oh, okay, it's kind of bouncing around a bit. Okay, that looks better. Looks better. Just check the stream length again. All right, it's gonna be a little bit of buffering. I'll check it again in a minute or two. But it's kind of a bummer. Yeah, so the double loop that I had would be effectively O of n plus n with those optimizations, but this one is a little bit more explicit. It is correct too, which is cool. O of n plus n. It seems odd that it's O of n plus n because it seems odd because of yeah, it gets to 0 milliseconds every now and then. It seems odd because of there are O of m by n elements. So even though I'm creating this vector, like this is probably the most expensive part of the whole thing, is creating the return values. Writing in the values is not that expensive. It's pretty cool. That's a good question, man. It's an interesting question. That was, I might say, it's a little more ad hoc, this question. I'm not sure what to say about it, but that's definitely, it's a tough one. That's a tough one for sure. Not a tough one, but not the most obvious. That solution. All right, how are we doing? Okay, stream's healthy again. That's good. All right. Let's continue. Number of strings that appear as substrings in a word. Given an array of strings, patterns, and a string word, determine the number of strings and patterns that exist as a substring in a word. Substring is a contiguous sequence of characters within a string. An array of strings, patterns, and a string word return the number of strings and patterns that exist as a substring in a word. Substring is a contiguous sequence of characters within a string. So patterns, word, 3. A appears, ABC appears, PC appears, D does not appear. Okay, so this is a pretty straightforward one. It's going to be a COUNTIF, I think. And we're going to say patterns, that size, patterns, oh, excuse me, that end. So begin and end. And then this is going to return a Boolean. And it's going to be constant string S, and this is just going to be word. This also could be reference. And you just return stood or just word dot substring S is not equal to string position. Something like that. I think that's all I really need. Okay, string to size type. I need to look at the substring team. Also see how more buffering, kind of a bummer. Kind of a bummer. Hope it doesn't keep buffering. Where's the oops. Not that one. For some reason, the browser doesn't always work quite the way I'd like it to. So basic string position count. That's not what I want, actually. Looking for string, the other one, I guess find. Search. Okay, find, I guess it's just find. Yeah, string position, okay. Could do that. I think string 0, yeah. Something like this. Okay, yeah, it's a COUNTIF. Very straightforward. Yeah, there's not much more to say about that. That's about as simple as it gets. Minimum number of steps to make 2 strings an anagram, 2 characters. Okay, this one I kind of already know. Any character T replace another character. Minimum number of steps to make T an anagram of S. Same characters with a different or the same ordering. First A and T with B. This is an anagram of S. So basically, I'm pretty sure I know what I need to do here. I'm going to give, I'm not going to do too much explaining here. I'll just kind of program it. Frequency 1, frequency 1, frequency 2. Apparently these are both zeros. I set them initially. Default initialized to 0. And it's going to be int result 0 for I 0 I. So I have to build these frequency maps first. Const char ch and s. Frequency 1 of ch minus a. Increment, double increment. Same thing for t. So we're going to get the frequency map, count the number of characters of each. Start with that. And then we're going to add the absolute values and the differences between the two for each of these frequency maps. So frequency 1 of I minus frequency 2 of I. I think it's that simple. I think it's something simple like that. That's how many times. Actually, I could be wrong about this. I might have to divide by 2. Yeah, I think I have to divide by 2. Yeah, it's the number of differences, but it's also, yeah, divide by 2. I think that's it. The reason to divide by 2 is because the operation actually moves two positions at the same simultaneously. All right. Surprised it's not the absolute optimal. It's pretty quick, but not the. Should be 100%, I think. I don't know. Can I make this faster? Is there a way to make this faster? I mean, I could make this static here. It could work. In which case I would need to fill them both. I don't know if that's a good idea. But actually saves me any time. Static could help. Maybe make it faster. Yeah, that made it faster. Okay, pretty good. Pretty good. How are we doing on the? Oh no, we're buffering again. No, buffering is such a bummer. It's such a bummer. Let's give it a moment or two here. Stop buffering. Oh no, it's all over the place. Okay. Try again. Yeah, it's a bit of a rough one. But yeah, that's a faster solution for sure. It's probably about as fast as it gets. It's about as good as it gets. Okay. Check if digits are equal in string after operations. Give a string S consisting of digits. Perform the following operation repeatedly until the string has exactly 2 digits. Consisting of digits. 2 digits. Okay. Each pair of consecutive digits start from the first digit. Calculate a new digit as the sum of the 2 digits modulo 10. Place S in the sequence of newly calculated digits. Maintain the order in which they return true if the final 2 digits in S are the same, otherwise return false. So this is an interesting question. This one's challenging. So there's only 100. There's a much harder version of this, where the string is like 10 to the 5th. The way that you solve that one has to do with calculating combinatorial functions, and the basically Pascal's triangle. And the optimal way to do it involves using some pretty sophisticated techniques to calculate large combinatorial values modulo 10. So there is an interesting way to do this question, but I'm not going to do it here. That's sort of the hard answer. That's definitely more of an ad hoc type of thing too, or more of a math type of thing. But the simple approach is to just simulate this. So we'll do that. So interim or just t, and we're going to say while, or just a for. We're actually going to, yeah, we could do it like so. This is going to be t.size is, actually, let's do it like this. We're going to reuse s and t multiple times. So s.size is less than 2 or greater than 2. We're going to set s equal to t. Say for each const char ch, it actually should be int I is 0, I plus 1 is less than dot size, increment I. Actually going to increment by 2. And we're going to say t dot like append or push back. It's going to be s of I plus s of I plus 1 modulo 10, subtract, both of these subtract 0 twice. And then after doing that, take this mod 10 and then add 0, which is a bit odd, but that's what it is. And that gives us t, and then at the end I think we return t is 0 equals 2. Set t equal to the empty string. So set s equal to t here, run this loop on t. Yeah, so just simulate, I think. Yeah, I'm gonna go for it. I think that's probably correct. Not still buffering, which is good, but I think oh, it's wrong. Oh. Whoops. Oh, what did I do? Whoops. Yeah, the better solution is a little more complex. I'm not going to go over it here because this is one of the easier versions. They expected true. I got false, so that's a bummer. What did I do? I'm supposed to. Oh, I did this wrong. It's quadratic time, not n log n time. Oh, I messed that up. I messed it up so bad. No, this is I plus plus I. Yeah, that was my mistake. I goofed, man. Whoops. I kind of forgot how this question works. It's not every pair. It's not every pair. Well, it is every pair, but it's every digit and the consecutive digit combined, but also it repeats, like it I don't know how to express that. So it's not every pair exclusively, like every 2, it's this digit with the next digit, and then that digit with the next digit, and then that digit with the next digit. So each iteration, you only decrease the digit string by 1. You don't cut it in half. You decrease it by 1, which is actually very meaningful, subtle and meaningful. Yeah, This unfortunately is not going to be the fastest solution, which is kind of a bummer. Yeah, that's okay. That's all right. Yeah, like I said, there is a much faster solution that basically comprises of like the hard version of this is the same question except the constraints amplified to 100,000. I've solved that one, 100,000, and instead of 100. And the way you'd solve it is using you're going to calculate the multiply each digit by a combinatorial factor. The combinatorial factor is potentially very large if you have up to 100,000. So then you've got to use, and you're doing this modulo 10, each of those combinatorial factors. So you've got to use some fancy mathematics that can do modulo 10 in very large combinatorial factors, which a lot of the time is actually just zero. But in a significant number of the time, it's not zero. And yeah, I think it's a combination of mod 2 and mod 5. And then you use I think the Chinese remainder theorem to build what it would be mod 10, which is also kind of fancy. So instead of doing mod 10, you do mod 2 and mod 5, which mod 2 is very easy. Or not, I don't know if it's very easy, but mod 2 is easier, I think. I actually have to think about that, whether or not that's easier or not. I'm not sure. I think I was able to figure out a way to do a mod 2 that was like pretty um fancy. That was a lot easier. Uh yeah, because if you do factorials mod 2, no, I'm not sure if it's easier if it's mod 2 or not. But anyway, do mod 2 and mod 5 separately, and then you combine that using Chinese remainder theorem to get you mod 10. But I don't remember exactly how to do it. It's some fancy math. Excuse me, sophisticated maths. I'd have to look it up again. Actually, might as well. Might as well. How to compute a large NR combinatorial mod 2. Combinatorial. Lucas theorem, NR in binary. Then N choose R is the product of N sub I R sub I mod 2. N choose I N sub I choose R sub I. N sub I R sub I are bits of N and R. The result is 1 if only if every bit is less than or equal to the corresponding bits. Also Lucas theorem. Compute each. So Lucas theorem. What is N sub I? What R? I should say what R. Ith digit of N base P. Ith digit of N. Ith digit of R in base P. Is there an efficient way to calculate those digits? I think you can do it efficiently. Oh, you just take a modulo of the digit and then divide by the digit amount. Huh. That's pretty easy. Oh. Hmm. No, cannot directly use base 10 digits to compute binomial and choose R mod 10 like Lucas theorem for prime moduli. Why it doesn't work? Lucas theorem applies only to prime moduli since 10 is 2 times 5 is composite theorem, doesn't hold in base 10. Use Chinese remainder theorem. Factorial prime power decomposition method works for any modulus. It's less efficient. Okay. Lucas theorem is logarithmic. Prime power decomposition requires factoring in factorial into primes, computing exponents, and reconstructing modulo p raised to the e, which is significantly slower. Mod 10 standard approach remains. Yeah, so using Lucas theorem with CRT is basically how you would scale the solution to 100,000 elements. Like I said, the way to understand how many times each digit would be factored into the final solution. It's not the complete final solution, but towards the bottom of the solution. It's very similar to calculating the Pascal's triangle. So it's like you end up with combinatorial factors for each digit. So you're going to end up adding each digit times each digit times the combinatorial factor modulo 10. And the combinatorial factors get very large at 100,000. So you'd want to use Lucas theorem with CRT, and then just take the sum modulo 10, the products and sums modulo 10. Tricky thing though is that you're not going all the way down, so there's a sort of off by one error potentially, and you just check that the two sums at the end are equal to each other. That's the optimal way to solve this, but quadratic time complexity works fine for it's not exactly linear time. It's like O of n times log of 100,000. Yeah, it's n log n, I think, technically. Yeah, it takes logarithmic time per combinatorial factor, which is going to be for each. You could potentially calculate the combinatorial factors one by one. I'd have to think about that, but I'm not sure if that's true or not. And do that in linear time. That's actually another idea. I don't know if that's a good idea. Not sure about that one. No, that doesn't work very well. No, that's a pain in the butt. That's a pain in the neck. I was thinking maybe because it's factorial, so you could, like, if you calculated n choose 1, you can calculate n choose 2 not too hard from n choose 1, but that's not really true. You're probably better off just doing Lucas theorem directly and do it n log n time. You might be able to do this in O of n time with a fancier approach to the, like I said, a more sophisticated approach to the dynamic programming, not dynamic, to the combinatorial calculations. But I don't think so. I don't think so, because you just run into issues with, even though it's this like falling factorial thing going on, you're still dividing by another factor each time, and dividing modulo 10 is pretty awkward. So you can get into some trouble with that, quite frankly. Yeah, you could say maybe divide by mod 2 and divide by mod 5, which are primes, which means you can actually divide effectively, and then use CRT to recombine. Maybe you could do that, maybe. I'm not so sure. I don't know. I mean, let's divide 0 mod 2. What does that even mean? It would be like the inverse is 0. Something times 0 is not. Nothing times 0 is 1. So, no. Even primes don't have a multiplicative inverse for 0. Yeah. So, no. No. Doing the division is not going to work nicely. So that's kind of the problem with you trying to be a little more sophisticated in that direction. All right, anyway, I'm kind of rambling on now about different ideas for this question, but this is an interesting question that has it kind of evolves into harder versions of it as we go. How are we doing on time? All right, about 40 minutes, 42 minutes in. Let's keep going. So yeah, I made a mistake there where I kind of forgot how the question works, got it wrong, and then I did got it right, but it's not the most efficient. It's O(n) squared instead of n log n. Hopefully I described the n log n solution. Zero indexed array of words consisting of distinct strings. The string words of I can be paired with the string words of j if the string words of I is equal to the reverse string of words j. Okay. Interesting. Turn the maximum number of pairs that can be formed from the array words. Note that each string can belong in at most one pair. Okay, 2 pairs of strings in the following way. 0th string with the second string as the reverse word is equal to words 2. Pair the first string with the third string. 2 is the maximum number of pairs formed. Okay, I mean, could use a hash set for this. It's probably the easiest way to go. Just put the reverse string in a hash set. Yeah, that's probably the simplest way to do this. So reverse string s in words. No, I do want to actually reverse this. And just have a count. So if so we're going to reverse start end, and actually no, we do it the other way around. So say if auto pointer is reversing dot find s if pointer is not equal to the first end, then increment the count. Actually, we're going to do that, and we're going to remove going to remove it from the set. Otherwise, still reverse, insert. Something like this. Yeah, I think that's it. I'm going to go for it. Yeah, it's pretty good. Not the best solution, but not a bad one either. Let me see. Let me see what feedback I get here. Yeah, I mean, it's pretty straightforward. Pretty simple. There may be a better way. Oh, it can't be at 100%, can you? Logical flaw. Okay, modifying the original strings by reversing them, which affects future comparisons. Modifies the input, changes the string in words. Correct pairing. First in the current string doesn't check if it forms a palindrome with previously seen strings. Interesting. Perform the check first, then I reverse and insert it. Store reverse strings and their indices. That's you end up just arguing with the chatbot. Okay. Optimizations. Two optimizations. String reversal overhead. All strings of length 2. Oh, really? Oh, I didn't even see that. Oh, that's a lot easier, huh? Huh. Use bitmask encoding. Oh. Oh, it's much cleaner. Oh yeah, I like that a lot. So we can use a fancier approach. We're going to convert these characters to base 26 numbers, basically. Static scene 26 squared, I think is like 76. Come back to that. 25 squared is 625. 26 times 25 is 25 squared plus 25, which is 650. And then 25 times 26 plus 26 is 26 squared. So 675. So 676. That's right. We're going to increment to 677 to... Actually, no, I think that's fine. Yeah. And then we're going to say if scene of, so constant key is s of 0, so s of 1, times 26, decrement by a, also decrement by a, and if scene of key, then we're going to say scene of key is false. Oh, I've got to reverse the key, right? Reverse key. Okay. If I see it, then I've got to increment the count and remove it. Otherwise, I've got to put the reverse key. Actually, I'm looking for just the regular key initially. And then I'm going to reverse and insert. A little bit confusing. So okay. All right, let's try this one. That's pretty cool. See if it's correct. Start with that. Might not be correct. Oh yeah, looks like it's correct. I was gonna say maybe it's not correct because I kind of slightly. There we go. I like that. It's pretty good. Let's check the time. About an hour so far. Stream's healthy. Got a couple. I have another hour or so. Safe but suboptimal. Okay, it's your initialize once a program start. No, it's not redundant. Static array will be filled. Values at each call. So I need to clear it. Reason I use static array because I don't want to keep reallocating memory slowly. Um, okay. Any other feedback? The optimizations, code, quality updates. I like being able to fix typos now. I like being able to fix typos. Crazy. What's up? Volgus YouTube or Volgus YouTube? Volgus YouTube. Welcome. Hello. Hope you're doing well. Welcome. Target improvements. Memset. Oh, okay. Memset. Is Memset really good? It's a really good idea. Place stood fill. Memset. Aren't they both about the same speed? I'd say it's probably not a good idea to do that. Const expert for array size, improve readability and safety. Okay, I like that. We'll do that. That's a good habit to have. const expert int static const expert int. Nice. And I also can do it. I don't have to calculate by hand. Like I calculated it in my head before, but you don't have to do that. Optimize the key calculation. Pre-compute multiplier. What? Constant. What? Is it what? Isn't this the same? Wait. How is step 3 different from what I did? What? LLMs are so much fun, aren't they? Unordered set for sparse cases. Word count of small hash integers may outperform array clearing. Already optimal for typical constraints. The main trade-off is zero initialization cost versus allocation overhead. Static rate was justified for unit calls. Interesting. Okay. Most modern compilers often optimize to fill them set for simple types. Okay. Typically compile the same assembly. Okay. So it guarantees performance, but stdfill is safe. Yeah, I just use stdfill. It's fine. Functionally equivalent. All right, still hung up on that. No. LLMs can't count. So if you're like, what about step 3? It's like step 1. Step 3. What? How could I optimize the key calculation? It's already optimal. Okay. It was like optimize the key calculation. And I was like, what do you mean? And it was like, no, it's already optimized. You're good. Okay. All right. So yeah, that's good. All right, we'll go to the next question. How are we doing on the stream health? That's good. Okay. Yeah, stream died on me before. It was pretty sad. It was a bummer. All right. Evaluate Boolean binary tree. You're given the root of a full binary tree with the following properties. Leaf nodes have either this value 0, 1, where 0 represents false. So it's a binary tree of binary values. 0, 1, false, true. Non-leaf nodes have either the. Oh no, excuse me. It's 0, 1, 2, or 3. Okay, never mind. So leaf nodes are 0 and 1, non-leaf 2 or 3, where 2 represents the Boolean or and 3 represents the Boolean and. Okay, so this is actually a Boolean expression tree. It's a little different. Valuation of a node is as follows. If the node is a leaf node, valuation is the value of the node. Otherwise, evaluate the node, two nodes, two children, and apply the Boolean operation of its value of the children's valuations. Return the Boolean result. It's like we're getting to what are those called? Expression templates. C++ has expression templates, which are pretty involved, quite frankly, pretty sophisticated. Return the Boolean result of evaluating the root node. Okay, this isn't too bad. This is pretty straightforward. Also, 1,000 nodes is pretty quick too. So 2 or 3 is or and, I think is what they said. All right. I mean, this is not too bad. So just recurse is the way to do this. We're going to use some fancy syntax here. Just nifty. This self, this auto double reference self. And then we're going to use, I think just a tree node. And then we're going to say recurse on root. And the way it's going to work is say if root is a root, if not root, return false, I think. Actually, it's just gonna be 0, 1, right? So if not root, return false. If root, and then we have we do and root val is less than 2, return root val as a cast, static cast to a boolean. How about that one? That seems reasonable. Don't need this if I do it this way. I could just do root val is less than 2. So now switch. Yeah. I mean, 2 turn self and self if root val is 3 and self or self. Actually, 3 is the and, 2 is the or. I would just always return false otherwise. I think it's that simple. This is going to be node left. Use root, should be node, not root. Made that mistake before. Yeah, it's just node left, node right. Node left, node right. I mean, I think it's that simple. I think it's that simple. There might be other ways to do this that are a little bit better, but this is reasonable. This is reasonable. 4 milliseconds. So slow. So slow. Maybe I could use a switch statement. There we go. Okay, 100%. All right. There's not much more to say about this. Let's see quickly if there's any feedback from the AI. Let's see what it says. I'm going to go to the next question. I might need to go back. Given integer n, return a counter function. This counter function initially returns n and then returns 1 more than the previous value every subsequent time it's called. Okay, we just use a static value. I think this is Java. Oh, it's in JavaScript. Oh no. Well, that's fine. Okay. Let result equal n. Function return result. And just this one. I think that's all I need for that one. Correct and efficient. Minor improvements. Return false. That's fine. Remove static boolean to bool conversion simplicity for clarity. Nah, I don't really need to do that. Okay, it's optimal for okay, fine. That's good. How about this one? Did this work? No, it's wrong. Okay, got it. You just subtract 1, I think. Let's keep it simple. There's other ways to do this, but that's probably the easiest way to do it. Just subtract 1. Okay, just gonna go for it here. I'm not getting into too much detail about what's going on there. It's JavaScript. It's JavaScript. You said JavaScript. Binary number in a linked list to integer. Binary number in a linked list to integer. Given head, which is a reference node to a singly linked list, the value of each node in the linked list is either 0 or 1. The linked list holds the binary representation of a number. Return the decimal value of the number in the linked list. The most significant bit is at the head of the linked list. I mean, this is a pretty straightforward way to do this. This is just, yeah, this is pretty straightforward. So results, assuming the result fits in a integer, you just say let's do current equals head, current equals current next, and then result, it's going to be bit shift left 1 and add current. It's something like this, something very straightforward. Yeah, I think that's it. I think it's that simple. Hopefully I don't have to explain that too much. What's going on there? That's probably about as efficient as I can get to. Calculate money in LeetCode Bank. So let's check the time and the stream health. So minute and 5 minutes, 5 minutes 6. Stream is healthy. Money in LeetCode Bank. Hersey wants to save money for his first car. He puts money in the LeetCode Bank every day. He starts by putting in $1 Monday. The first day, every day from Tuesday to Sunday, we'll put in $1 more than the day before. On every subsequent Monday, you'll put in $1 more than the previous Monday. Give an N, return the total amount of money I'll have in the LeetCode Bank at the end of the day. So this is pretty straightforward. It's a sum from the first 7 of like n to n plus 7, and then the next week it like restarts, but you add 1 value. So it'll be like n to n plus 7, then n plus 1, n plus 8, and so on. And they kind of explain it each of these. Which this is not too hard to calculate what's going on here. So we have 1 through 7, and then 2 through 4, and then 1 through 7, 2 through 8, 3 through 8. Okay. So we're going to do a few things. Firstly, we're going to count how many weeks. So first things first, constant weeks equals n divided by 7. The first week is a sum from 1 to 7, which is just, I think, 28. 7 times 7 plus 1 divided by 2. 7 times 4. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, plus 7 is, plus 6 is 21, plus 7 is 28. Yeah, so it'll be 28, and then you add 7 for each week after that. So it'll be 28 plus 28 plus 7 plus 28 plus 2 times 7, and so on. So it'll be 28 several times, 28 times weeks. So int total is going to be 28 times the weeks, right? But it's going to be 0 plus 7 plus 14 plus 21, which if you divide out the 7 is then 7 times 0 to weeks minus 1, which is weeks times weeks minus 1, bit shift divided by 2. I think that's the computation here. Yeah. I think that's it, actually. Oh, that's for the number of weeks. Then for modulo and modulo 7, you can just add directly. And that'll give you a constant time algorithm. It's wrong. At 34 should be 37. So how far off was I? 84 should be, I'm off by a little bit here. So 1 week should be 1 through 7 is 28. Oh, excuse me. this should be the number of weeks plus 1, I think. Yeah, actually should be, that should be something like this, actually. No, it's wrong. Maybe this is wrong. There's something subtle there. There we go. Okay. Yeah, I forgot the number of weeks that elapsed. That section at the end is going to be incremented by that amount. It's pretty good. Hopefully that wasn't too hard to follow. How are we doing time? All right. Snake in a matrix. There's a snake and an n by n matrix grid and can move in 4 possible directions. Each cell in the grid is identified by the position grid of ij equals I times j. Snake starts at cell. Wait a second. Is it commands and? Oh, we don't get a grid, do we? Okay. Starts at cell 0, follows a sequence of commands. You're given integer n representing the size of the grid and an array of strings, commands, which is up, right, left, down, or up, right, down, left. It's guaranteed that the snake will remain within the grid boundaries throughout its movement, trying to position the final cell where the snake ends up after executing commands. Okay, well, I mean, this isn't too hard. This is actually really straightforward, so it's guaranteed it's not going to move anywhere in the grid, then yeah, so yeah, I mean, okay. Let's see, initial positions to 0. So int row column for constant string s in commands s equals left. This is like a really straightforward one. Right, and then I could do this. Make it explicit. Okay, so up is row minus equals 1. Left is column minus equals 1. Right is plus right column, and down is plus row. And what do they want us to return? Int. Oh yeah, okay. So row times n plus column, something like this. Let's do right and down. Yeah, I think it's exactly. Yeah. I mean, this one, I don't know what to say about this. This is like just kind of, I don't know. I don't know what to say there. There's not much to say. Sort integers by the number of 1 bits. You're given integer array. Sort the integers in the array in ascending order by the number of 1s and their binary representation. In case of 2 or more integers have the same number of 1s, you have to sort them in ascending order. Okay, return the array after sorting. Yeah, so this is pretty straightforward. Could actually use counting sort. Could use a form of counting sort. I'm wondering, it's kind of funny that like there's not that many bits that you can use. 10,000 I think is only, it was log 10 log 2,000. It's like 10. It's 10, 11, something like that. But I'm not going to use counting. I could use a form of counting sort, but I'm not going to use a form of counting sort. We're just going to sort this with a lambda expression and keep it simple. Let's do return. We have constant a, or int a and b is fine. Doesn't need to be const. And we're going to use pop count. So there you could do std bit set 32 of a dot, I think, size or count. Let me see. I just want to double check this. Is this the correct syntax? Let's go to bit sets. Somewhere around here is bit sets. I don't know where bit sets are. Let's just type in bit set. We'll find out. Maybe it's numeric. General utility library. Utilities library. Okay, general utilities. And somewhere in there is bit set. Okay. Interesting. All right. Count. Okay, that's what I want. Count. I think it's gonna tell me yes, this is the right. What's up? May I ask you something? What's up, the Mythic Man? Hope your day's going well. Welcome. You check Claude, it will give you the links you need. Oh, Claude. I don't really like Claude. They want too much money, man. They want too much money for me, man. Too much money. Let's do we'll just do C1. Too much money. Too much money. Yeah, I gotta start charging money soon, I'm pretty sure. Maybe it's not Claude that's gonna charge money as much as it's probably the other one, OpenAI. Not so OpenAI. So we do C1 less than C2, or C1 equals C2 and A less than B. This is one way of sorting. It's kind of fancy. Use an or when the things are equal. And an or and combination allows you to do like a secondary sort. So this will sort them in ascending order. Okay, it's fast enough. It's pretty good. It's better intelligent software architect or data scientist. I guess it depends. What's the context? Better. I mean, Claude and specialize more in coding. Respectful amount of tokens. Yeah. It's a little bit better for coding. Yeah, when I asked this AI for, this actually uses Claude on it. Do you use Claude code under the hood? Sometimes. Allegedly it does. Intelligent software architecture data science. It depends on the context. Depends on the context. But yeah, depends. Yeah, let me not say too much about that. I was gonna say like I can make general comments about both, but let me not do that. Probably shouldn't do that. Unique elements which are in all possible subsets of the power set. Okay. Oh, I like this a lot. Yeah, nifty way to do this. We're gonna code. I'm pretty sure I've solved this already, but I think I did it a long time ago. I did it in C++ 6 years ago, so almost 6 years ago. Okay, we'll do it again. So my what I like to do for power sets is something like the following. So you start off with an empty set result, and it's just going to be a single empty vector. We'll do it explicitly here. And what we're going to do, constant x and nums, I'm going to create a vector vectors next. And this is going to be next.reserve result.size. Should be shifted twice. We're going to say for std vector int copy of result. I'm going to say next dot push back std move copy. We're not going to std move it. We're going to push back the copy, and then we're going to copy to push back. X, and then we're going to std, then we're going to move. Then we're going to move the copy. And then we're going to result equals next. I want to say, do we std move next? I think we move it each. I'm not sure if we move it or not. It's something like this, sort of power set. Whoops. Oh no. One click reset. Yeah, reset. Whatever I just did, reset that. I think that worked. Let's give it a shot. Yeah, there you go. It's efficient. It works. That's not too bad. Why you wrote std. What's up, sit on sing? Hope your day's going well. Welcome, welcome. The reason I did that is you don't want to pollute the namespace. And even though LeetCode allows it, LeetCode already uses using the standard namespace. It's not a good habit. So I do it. I do it to promote good habits for myself. Like I wouldn't in my code. I wouldn't write like using namespace std. In fact, I basically never use a namespace unless I think it's like appropriate to do so, but basically never. It's a good habit to just do it automatically without using namespaces. And then the reason is it's called polluting the namespace. You run into trouble when you have a lot of different namespaces and you have like conflicting overlapping names. It's not something I've actually not a problem I've run into very much, but I was told by other programmers that it's a good habit to have, so I've just always kept it that way. Also helps with your typing speed and you get fast typing stuff you type frequently. We're given two integers m and n, which represent dimensions of a matrix. Given the head of a linked list of integers, generate an m by n matrix that contains the integers in the linked list, presented in spiral order clockwise, starting from the top left of the matrix. If there are remaining empty spaces, fill them with -1, return the generated matrix. Interesting. Okay. M by n head. Okay, I could try this. So we'll start with a by the way, something to keep in mind though, when you're programming, the biggest cost is not the typing, it's actually the thinking. Which is also one of the reasons why AI is ultimately going to fail, because it's too expensive to think with AI. Okay. So we're going to do, the spiral is going to be each leg. We're going to go through 4 legs, and we're going to toggle the direction of each leg. So we're going to have a toggle equals false. We'll start with true. We'll say reverse. And then we're also going to have a direction. It's going to be 0, 1, 2, 3, or 4. We'll start off at 0. Like an enum might be good here. an enum. I'm not going to write an enum. I'm just going to set direction. So we'll come back to this in a moment. So if direction is 0, it's going to be east. It would be better to do. Actually, this. I'm trying to think of how I want to do this exactly. I don't really need to. I don't really need to reverse if I'm going to use the directions like this. It's easier to do it this way, I think. And we're gonna direction equals direction plus 1 mod 4. Okay. So in this loop, so the way I'm going to do this is I'm going to have an initial position, row, column. Just going to start off in the top left corner. And I'm going to say this node head. We're just going to actually make sure we have something to write. Let's do this. So I'm going to have a length. And that's going to start off at, oh, that's what right. So we'll do row length, bar length, and then column length. So the row length, that leg is going to be M or N, it's the number of rows, and the column length is M, is the number of columns. Number of rows is the column length. Yeah, a little bit confusing, but that's how we'll do that. And then what I'm going to say is, and it's going to start with -1. Each case is -1. And so if I'm going to the east, I'm going to say int I equals 0, I is less than the row length. Yeah. Yes. And I'm going to write to the row, so result of row column equals current value. And I'm going to increment the column. Yeah. Which is a bit odd, but that's how we're going to do it. And then we do the same thing for each. So now that we're going down, it's going to be very similar. It's a column length, and it's going to increment the row. And a little bit of duplicated code here. This one goes back to the row length, and now it's decrementing the column rather than the row. And then, unfortunately, I have some duplicated code here, which is not great for debugging. And then this is the column length again, and decrementing the row. Okay. It's something like this. And it just keeps going. Yep. I think that's it. We could try that, see how that goes. It could be wrong. What's up, chat? Used to write it when we're coding with C++XD. Again, avoid writing to make my code seem less clustered. Means to not always necessary, but sometimes it fixes logical bugs around runtime, so sometimes it's that useful. Yeah, I guess logical bugs can be fixed by better logic only. Where are you from, buddy? I am from the USA. 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 Oh, runtime error. Whoops. Interesting. What did I do wrong? Okay, yeah, I might need to do some debugging here. This shouldn't actually. I may have made a mistake somewhere. Not expecting this to have issues. All right, let's just see what's going on here. Try to get an idea. I goofed somewhere around here. This is it's pretty custom code, so room for error is 0, 1, 2, 3, 4, 5. Oh, I think I know. Do I know? 5 columns. What did we say the M and N is for this first case? N is 5. M is, tell me it's the rows and the columns. Yeah. So N is the number of columns, 5 columns. So, but this should be not 5. This should be 4. So it should be 0 to 4. Right? Row length is the number of columns. I probably should do, yeah, row length. That's fine. Row length, it's number of columns is 5 columns, minus 1 is 4. We're going to do, oh, you know what? We're going to write it. Yeah. 1, 2, 3. So 0, if we increment 4 times, 1, 2, 3, 4. What is this? I'm pretty sure it's an off by 1 error, but it's a little bit hard to tell exactly what it is. Okay. I think it's just an off by 1 error. My logic is I'm not explaining all the logic, but I think it's really close. Yeah, it's 4. So 4 times we add. Why does it go to 5? Oh, I didn't increment I. Oh, duh. It's not an off by 1 error. It's an off by. It's an off by. Oh no. Oh. That's what I get for duplicating code, by the way. Have to write it 4 times. It's an off by whatever you want to call that error. Output 0, 0. That should be a 3, yeah. Why is that a 0? What's going on there? Shouldn't this just write directly to... What happened to my debug code? Where did I put that? What is happening? Yeah, this should have written to the first row. Or did it write again to the first row? Oh, that might be why. Oh. wasn't supposed to do that. Oh. Oh, I forgot something really important. I forgot. That's actually matters a lot. Ah, decrement the row length. That's what I was supposed to do. Decrement the column length. Oh, that was what the toggle is for. No, it's only first direction, second direction, the third direction I decrement. Third and fourth directions a decrement. Yeah, that's really subtle. I forgot about that. It's important. That's what makes the spiral. Okay, still shoot. Um I did something wrong here. Forgive me, this is probably one of the less appealing parts of the stream. Debugging. No, I still overwrote it. Why? No, man. No. No, there's something wrong here. It should be 4, 4, 2, 4, 4, 2, 4, 1. Oh, that might be the issue. 4, 2, 4, 2. Oh, no. Okay. Yeah, that's a mistake. I think this actually gets decremented before. And then when I go across, that's confusing, huh? Wondering if maybe I do it in the in-between. Maybe that's the issue. Yeah, that's subtle, huh? That's a subtle off by one error type of thing, huh? Yeah, the basic spiral idea is not too hard to understand. It's just, you just go the row, leave a space, column, leave a space, the row again, leave a space, the column, leave a space, and just keep repeating spiraling. And then each cycle you just kind of squeeze into a smaller loop, and that's the idea. It's kind of like an onion. But getting it just right is not the easiest thing. Hopefully it's right. Could be wrong. Oh, that's a good chance. I was gonna say it's a good chance there's something I did wrong here, because I didn't test this on anything. It's like very error prone, this approach. I'm sure there's a better way to do this. It's not so error prone. No. Yeah, this is not a great solution. At least not the way I'm programming it. Sure, there's a better way to do this. Hate it or not, nowadays devs are meant to focus more on defining structure, logic, and architect, whereas AI is more responsible for coding. Just provide with a clean and well-structured prompt. Hard but true. Yeah, but trust me, bro, AI ain't replacing devs. It's just replacing devs who are not adopted to AI. Cannot replace humans' logic after. Message retracted. So the deal with AI is it's actually not as smart as people think. It's actually really far off from being really smart. So it's not a good idea to use it even for coding. Like even people adopting it, using AI to use it to code, they're actually going to be more of a liability, those people, because they're going to write a lot of code that can't be maintained and is probably wrong. Adopted. True. Yeah, unfortunately, it's like if you hired a whole lot of people that are really bad at programming and make a lot of mistakes. It's actually a liability. It's actually like negative. Like it's a lot of extra work for yourself. Um, and you would think that people who adopted using AI tools would have an advantage, but actually, like I said, it introduces so many problems and makes it so many. It makes the code. It's a tremendous amount of code that you need to maintain, and you don't have enough resources to maintain it. And there's a lot of mistakes. You don't know where the mistakes are. It's like impossible. Not that it's impossible, but it's costly to find all those mistakes. So it's actually a liability overall. Like broadly speaking, these tools are actually just a net negative. Um, they have their place, but not for programming. Not really. Like I said, the main issue is that it's twofold. The AI is not smart enough. They're trying to make it as smart as they can, but it's not smart enough. Um, and also, it's not smart enough and efficient enough simultaneously. So, like the human brain is like 20 million times more efficient than silicon when it comes to the kind of processing that AI does. Um, so it'll never be smart enough, basically, to replace humans because humans will always be 20 million times more efficient. Um, yeah, so it's just really expensive. Like you could replace people if you pay 20 million times the price. So it's like you could pay somebody or pay 20 million times that. And it's like, all right, you can replace them, but it's not really worth it. So that's kind of the issue. It's kind of the issue. Um, but I don't mean to say it can't do some things, that it can't automate some things, but broadly speaking, it's actually not really that good. And it probably never will be, quite frankly. Um, so, all right. So I have an error here. I don't know what the error is, though. I mean, I could print what I'm expecting. Um, yeah, I mean, let's print the results. Let's just do that. That's an easy way to see what's going on here. Let's do row, or let's do I and J. Let's do that way. What do you say? M and N? Yeah. M, N. Okay. Just gonna put a space. Really simple printout here. Okay. Just print what's happening. All right. So what I was supposed to do was 1, 2, 3, 4, 5, 6, right? Up to 915. Then it starts going down. 1, 2, 3, 4, 5, 6, 7, down to 481. 1, 2, 3, 4, 5, 6, 7. Okay. Then it should go over 6 again. 1, 2, 3, 4, 5, 6 to 305. From, was it 972? 1, 2, 3, 4, 5, 6. Okay, yeah, something got overwritten. Yeah. Okay, I see a problem. Okay, so something got overwritten, but it was supposed to do that. It's supposed to do like move over to this side, then move down here, then move over here, move up here. It's supposed to spiral. Okay. So something got overwritten. Maybe I don't want to print every write, but I feel like maybe I should do that. I mean, okay. Sure. It's fine. Not ideal. This will give me a sense of where it went wrong. And I should put the value. I should maybe do it like this. Put this on the same line. All right. By the way, they're really trying to replace people. Holy smokes. They're like chomping at the bits to automate people away. They like can't help, they like can't wait to replace everyone with AI and robots. It's like unbelievable. It's kind of disturbing, actually. Okay, so initially we got row 0 over to row 06. We write this value. Then we go down the rows from column 6 down to 7, writing all these values. Then we should be moving back over, column over to on row 7 to column 0. Then back up again on column 0. Then on row 1, moving over. Then moving on column 5 down column 5, then moving on row 7 to the left from column 4 back to, okay, so this should only go back to column 1, not column 0. So there's the problem. There's the first problem. That is coming back. Yeah, I'm pretty sure this is the issue. Pretty sure I know what the issue is. This is not supposed to be this one. It's supposed to be, I think both of these are supposed to be like this. I think it's supposed to, that subtraction is supposed to happen on the first iteration of both sides. No, that's wrong. No. No. What? What is going on? All right. That's funny. Gulp. Oh, this is RL. Hold on. RL here, and then CL here. I'm gonna try this. This seems wrong, quite frankly. This is probably wrong. Yeah, this is just wrong. No. It's confusing is what it is. Maybe it was supposed to be here. These two. RLCL. No. Part of me thinks it's supposed to be in a different spot entirely. Part of me thinks it's actually supposed to be right here. And the other side is right here. Oops. Yeah, there's a part of me that thinks that that's the correct logical spot for this. No. My goodness. Oh my gosh. Oh my gosh. Okay. Why? All right. So 0, 0. So, okay. The first iteration, 30268, takes us over the fourth column. Okay. That's what we expect. Well, I got overwritten, but 30268 takes us over the right side, the last column. Then 17942 takes us down. Oh wait, no, we just go 8. So 1 7 down to row 2. Okay, so it's 3026 81, or excuse me, 30268. Yeah, this is actually part of the next loop. So it goes 817. I think it's just 81 actually. This is very confusing. Let me try to think this through again. Why is this not working? So I write the value where I'm at, then I increment the column, and I want to go the row length -1. If the row length was 2, this would be 0 and 1, and the row length starts off with a -1. Because I don't want to go the full number of columns. Okay. And I end up at I think I'm supposed to subtract more than 1. That might be why. That might be the issue. That actually, I might not be doing enough subtracting. I didn't think that all the way through, did I? No, I did not. That might be the issue. Now I'm thinking a little bit harder about it. No, that's not right either. It's funny. The reason is that on the spiral, when you move across, move down, move over, move up, when you move over again, you need to do 1 less than you did previously. When you move down, it's now 2 less because we're shifted 1 row down, and we're not ending at the bottom row, we're ending at 1 before the bottom row. So this is actually a -2 when we go down. And then same thing when we go over, it's a -2 again. Oh, okay. That's confusing. I'm very tempted to just define the bounds and you just go all the way to the bound. That's a lot easier than trying to math this out. Well, okay. So let's try again. I had the slightly wrong idea. Close, but not quite right. So we move over, down, over, up. Moving over the first time is fine. We do sort of row length -1, leave 1 space open. Move down, move over, 1 space open. It's when It's when we'll come back to that. I think it's RL minus 2. Oops. I think it's minus 2. Over, down, over, up. And when we go up, it's the same. It's the same amount that we move down and move up, I think. What did we say it was? It was the column length. Yeah, it's column length minus 1. And then we're at that next position. Row length minus 1, we're at the next position. Column length minus 1. Actually, at that point, we don't want to go all the way back to the beginning. Yeah. That actually should have a minus 1 on it. The last iteration should just get a minus 1 right out the gate. And then when we row length over, it's also a minus 1, which I think we would have the minus 1 here. So it's row length minus 2. When we move down, oh, it's so confusing, huh? When we move down, we would get another minus 1. No, I don't need 2 minus 1s on that one when we move down. Yeah, no, you do need 2. Yeah, you need to get another minus 1 moving down. That is confusing, huh? Now how is that supposed to work around? It's the spiral. If it was a square, let's say it was let's say it's 5 by 5. We would move over 4 from the first leg is 4. Then we move 4 again. Then we move 4 again. Then we move up 3. So 4, 4, 3. Then it should only be, I think, 3. Then it should be down. You're going from row 1, 2, 3. You're not going to row 4. So I think you go down 2 at that point. So it's like 4, 4, 4, 3, 3, 2. And then that's column 3 to column 1, which is also 2. And then row 4 back to, now it's not row 1 anymore, it's row 2. 2, 2, 1, 1. Yeah, that's a bit odd, huh? I think it is easier to just go all the way through. Let me see something here. Just reset the bounds as you go. The values are negative, never negative, so I could use those as. Also, it's giving me this. It's like you tried it and failed. You tried it and failed. That's what that symbol means. I kind of goofed on this, huh? My logic is just wrong. So let me use some different logic, and I'm just gonna write the the leg sizes. I made a mistake here. My logic was wrong. No kidding. Okay, I thought it was easier than this. I mean, it's not that hard. It's just the basic idea is correct. The logic, though, is slightly off. All right, so an easier way to do this is just you would say C is less than N, and result of RC is not equal to, or is not equal. And then you don't need to increment I, do anything with I here. This is a little bit easier. And then you do the same thing on the other side, similar kind of logic, different bounding logic. Oh, end current, by the way. So on this side, we would do R is less than M, and result of R, C is not equal to -1. Oh, excuse me, is equal to -1. Sorry, we're only going to write to -1. What did I, what? Oh, that's why. Don't need I anymore. Oops. Yeah, this logic is a lot easier to follow. And then I could print the number of steps that were taken. So I'm having a hard time kind of thinking this through logically in my mind. It shouldn't have been so hard for me to do this, but I kind of just got stuck on it mentally. Something like this. That's a bummer that I got this wrong, though. That is a bummer. Okay. Immediately runtime error. It's always good. And by good, I mean that's not great. It's not great. Okay. Oh, I need to reset C. I think C plus 1 is less than N. R plus 1 is less than C minus 1. I could be wrong about this, but that might be correct, actually. TLE. No. Okay. I think the issue is when I write to this value, it's going to go off the edge now. We could just do if C is greater than equal to N. Just reset it back to, oh, hold on a moment. Sorry about that. Well, it's this, yeah. How are we doing on time? Okay, we're actually a little bit over time, but let's finish this question. Yeah, okay, so this is maybe not the best logic. Let's do. I think that's what happened. Is that basically this incremented and then went into the next loop, and then and then had a runtime error. Excuse me. This is just some if statements to prepare for the next. I just want to see if this will work. Excuse me. Okay, let's try this. Not TLE. No. So even though this is simpler logic, it doesn't work. Go figure. Why? I feel like this should be easier. Like I should be able to do this a little more easily. I don't know. I guess it's the logic. I have to think more harder about this question. I think that might be it. I've solved this before though, and why is it TLE? Let me print all of these. We'll do all of them. Yeah, let's do that. Yeah, I am not so sure about this. Guess I gotta think it through a little bit more. What happened here? Can't I do this? Oh, that's why. Right, that's so. I think I could do this way. That's subtle, but it's an easy mistake to make. Kind of going quick here. That's what you get for having duplicated code. You got to do it 4 times at every spot. I think I've said this before. The problem with duplicated code is actually debugging. Like when you're developing, it's just too tricky to debug what's happening. Oh, whoa. It just stops here, huh? Goes 0, 1, 2, 3, 4, and then just stops. TLEs. What? Why is that? What? What is going on? Huh? Presumably it's just printing this several times. What is happening? Awesome. Sorry, I'm a little distracted too. Yeah, it should be. It's just repeating this over and over. Well, that doesn't make a lot of sense. Shouldn't it do. The direction is 0. And then after all these if else statements, it is up. What is happening? Doesn't call any of these other statements? Oh, I wasn't expecting that one. There's probably something like a typo or something small that I missed here. Okay. It's not the question that I'm taking a deep breath over. It's the, I mentioned there's real life things to deal with. Yeah, it is cycling 0, 1, 2, 3, but it's not entering any of the other for loops. I think, oh, that's why. Oh, that makes sense. Okay, that's the reason. Got it. That's subtle. Okay. So the reason it's having issues is that the way I wrote this logic, it's stopping on the edge, on the very edge, and when that happens, it doesn't check that the thing I'm about to write to is a -1 there. That's why. Oh gosh. Okay. Hmm. I could just do C+1. It's less than n. It might be easier. I think I tried that a moment ago though, and that didn't really make sense. But I could try it again. Get an idea of what's happening. All right. What's up, chat? True, not all sides decrease. Actually, 2 sides increase to reduce the circle and 2 DC to reduce the circle. Something like that. Yeah, it's a bit odd. It's a bit odd how it moves. Okay, this is a little bit better. Then it just keeps cycling. Okay, so I do it this way. 0, 1, 2, 3. Then 0, 1, 4. Then 2, 4, 3, 2, 1. Then up 1, 2. But this is still column 0, which is not correct. Yeah. Stopping conditions when it's not equal to -1. It really should be +1 or -1. It's the next position that we stop at. It's something like this. So the current position we assume we can write to, it's this next position. So we're always going to be in a position that we can write to. Yeah, there's some subtleties here, I think, that I'm not really working through properly. Something along these lines. I don't think this is right, though. Oh, okay, now it's right. And now it's correct, so of course. All right. Well, let me actually, just because I gotta get going, have some family things I gotta deal with here. Let me submit this. This was not great on my part. I should analyze this a little bit more. I should have been able to do this really fast, but I got it wrong initially, had the wrong logic like several times, and then finally got something that looks correct. But this took me way longer than it should have, I think. Well, I shouldn't say that. I should say I should analyze this. Oh no, is it wrong? Oh no, it's still not right. No, say it ain't so. It's a bummer. Okay. No. Yeah, I shouldn't say that I should have done it faster. That's not really correct. Like the way it works is that you get things wrong and then you adjust. Oh, I took all the debug statements out too. Oh no. Yeah, that's how it works with the brain, is that you get feedback that the thing you're thinking and doing is wrong, and then your brain adjusts. So actually it's supposed to be like this. Okay. So what happened here is this has 10 rows and 1 column, and I went through 0 through 8, and I didn't touch 9, and I should have. Yeah. Okay. All right. I hate to stop here, but I think I need to stop here. So yeah, my logic is a little wonky here. Hold on. All right. So let me recheck quickly. Okay. Oh, yeah, not great spot to end on. I'll come back to it. I'll come back to it. But yeah, there's some logical issues here that I need to address. And yeah, it's a bummer to be pulled away at this moment, but it's okay. Not the worst thing in the world. All right, let me get going. Thank you for watching. I will chat with you soon. If you like the stream, don't forget to like it, subscribe. We'll come back to this question. Yeah, I should know how to do this. I've solved this before. I think I just gotta think about it some more. We'll be all right. This is, by the way, this is like when you're learning stuff, problem solving. Like this is very normal. Like you basically get something wrong, and then you have to like think about it, and then you get it right. That's just how it goes. All right. So yeah,